Very good morning to all of you. Sorry, some technical problem was there. That's why I have to change that link. Can you hear me? Please tell me. Can you hear me? Yes or no? Very good morning to all of you. Okay, yes, sir. So some technical problem was there while going online. Okay, Madhuri is saying, sorry, Madhukar is saying, yes, sir, you are audible. Okay, so extremely sorry for that. Hmm. What we were talking about? We were talking about, I think, chemical kinetics, chapter number one, which is very important topic as far as your SY is concerned and chemistry subject is concerned. Okay, so we were discussing about the integrated rate laws for different order of reactions. And in last lecture, I think we have finished the integrated rate law for first order reaction. Okay, so today we will see the integrated rate law for second order reactions. Okay, and we will derive one equation for a second order reaction, rate equation for a second order reactions, and after that we will see some characteristics of these reactions. So which characteristics are there? Three characteristics are there. Unity is there, half-life period is there, and we will see the nature of graph. So nature of graph means after performing an experiment, and if you want to plot a graph, and or if you want to determine or calculate the rate constant, that is k, for a different order of reactions by using a graphical method. So in that case, that nature of graph is very important. Okay, so what we were discussing. So here second order reactions means the order of reaction is 2. That means in the rate equation your concentration term will have exponent 2. Your concentration term will have exponent 2 if the reactant is only one. If the reactant is only one reactant is there, that in that case your rate equation contains the exponential term is 2. And if two reactants are there, for example say A and B, then what happens, each reactant will have exponential term 1 in the rate equation. How this is we will see. Okay, so we will start our lecture. This is your lecture number 4 of chemical kinetics. ठीक है, ये आप लोगों का लेक्चर नंबर 4 है केमिकल काइनेटिक्स है. And in this we will see the integrated rate law expression for second order reactions. Integrated rate law equation for second order reactions. And in this, now as I have told you, in this second order reactions the exponent of concentration is concentration term is 2. The exponent of concentration term is 2 when it is 2, when the only one reactant is present. For example, say reaction A goes to B, in that case only one reactant is there. In that case, in that reactions your rate equation will contains exponent of concentration term is 2. And if two reactants are there, for example say reaction A and B, then each term has a one exponent. See, we will see the example here. If you see here, example number 1, it is a thermal decomposition of HI. So decomposition of HI is takes place here, and here 2 moles of HI will give you, not plus symbol is here, plus symbol नहीं यहाँ पे. My mouse is not working. Why it is not working, I don't know. ठीक, mouse is not working. I will take here a pen, and still it is not working. Forget about this. So here two reactants are there. Okay, 2 HI will give you H2 plus I2. This is reactions. Now here only one reactant is there, HI. Only one reactant is present, that is HI. And if you write a rate equation for this reaction, it will like this. It will be like this. Okay, so R is equal to K. Sorry, here K2 is there. Why K2 is there? Because it is a second order reaction. So R is equal to K2 concentration of HI exponential term 2. So here the exponent of concentration term is 2. Why? Because only one reactant is present. Why? Because only one reactant is present. It is not working. Some problem is there with this. I don't know. Let me check it. Now it is working. Okay. So here the K is 2 because it is a second order reaction. K is 2 because it is a second order reaction. So second example we will see. Example number 2 is hydrogenation of ethylene to the ethane. So it is a hydrogenation. That means addition of hydrogen is takes place across the carbon-carbon double bond. Ethylene contains a carbon-carbon double bond, and addition of hydrogen to the carbon-carbon double bond, it is called as a hydrogenation reaction. See here H2 plus C2H4 will give C2H6. So again here two reactants are there, and if you want to write a rate equation, here I will write the rate equation for example number 2 will give K2 concentration of H2 into concentration of C2H4. So this is two terms are there, and each terms has a exponent, here 1 and here 1. So two cases are there. Please remember this, and we have to find out the integrated rate law expression for both two cases, that we will see. Okay, so let us start with the cases first. See, case 1 is, which we have discussed already. Case 1 is what? 2A, that means only one reactant, 2 molecules or 2 moles of A reactant will give you a product. And case 2 is there. Case 2 is means two different reactants are there, A plus B, which give you product. So these two cases are there. In case 1, the only one reactant is there. In that case, rate equation contains exponent of concentration term 2, and in second case, two reactants are there. So rate equation contains exponent of concentration term is 1 for each reactant. Okay, so let us start with the case number 1. So let us start with the case number 1. Case number 1 is 2A gives you product. So for this reaction we have to write the rate equation. How will you write the rate equation? See, rate is equal to negative dCA. What is this Ca? C is the concentration of reactant A. dCA, in that Ca is the concentration of reactant A, and negative sign indicates the rate of reactant is decreases. So dCA by dt, this is the rate equation. Again we will write it in the form of R is equal to rate equation. R is equal to K2 C square A. Why C square is because 2A is there. 2A is there. That's why C square is there. So R is equal to K2. What is this K2? It is a rate constant for second order reactions. Please remember this. This K2 is a rate constant for second order reaction. Rate constant for second order reaction. Okay, so this K2 is rate constant for second order reaction. So this in this way we will write the rate equation for this above reaction, that is case number 1. So now let us consider if A is the initial concentration of the reactant A. Now let us consider A क्या है आप लोगों का? It is the initial concentration of reactant A, this reactant A, and if X is the number of moles of the product formed at a time T, then we will give the X, which is the number of moles of the product formed at a time T. Then the concentration of unreacted reactants A. Now we will find out the concentration of unreacted reactant A. How will you find out? At a time T, it will be A minus X. It will be A minus X mole, and which is evidently it is a Ca. So A minus X is nothing but the concentration of A, which is remains unreacted. Now we will substitute this value in equation number 1. We will substitute this value. A is the initial concentration, X is the number of mole product formed, and unreacted concentration of reactant A is A minus X, which is nothing but the Ca. So we will put these values in the equation number 1. We will get, this is your equation number 1, R is equal to K2 C square A, and in this we will put the value. We will get minus d concentration of A minus X by dt equals to dx by dt equals to K2 A minus square. K2 A minus X square. This equation we will get. Now we will rearrange it. What we will do? We will take this dt term to the right hand side and this A minus X square term to the left hand side. And after rearranging, we will get this equation dx divided by A minus X square is equal to K2 dt. So we will get the equation number 3. We will get equation number 3. ये equation आप लोगों को मिल जाएगा dx divided by A minus X square is equal to K2 dt. Now we will integrate this equation. हम लोग क्या करेंगे? We will integrate this equation number 3. ये equation को हम लोग integrate करेंगे within the limits of time and concentration, within the limits of time and concentration. So for time t is equal to 0 to t is equal to 2, and for concentration x is equal to 0 to x is equal to x, then we will get this. We will get integration 0 to x dx by a minus x square, which is equal to integration 0 to 2 k2 dt is equal to k2 integration 0 to 2 dt. Now why we have removed, or why we have taken outside this k2? K2 is a constant. K2 is constant. It is a rate constant for second order reaction. So we will get this equation after rearranging. Then we will solve this equation. We will solve this equation. A minus a, sorry, 1 divided by a minus x, x to x, which is equal to k2 t 0 to t, and we will substitute lower limit from upper limit, and we will get a minus x into a by a is equal to 1 divided by a minus x into 1 divided by, which is equal to k2t. This we will get after subtracting the lower limit from higher limit. Okay, and we will rearrange it. Now we will rearrange it. What we will do? We will take this, or we will solve this. We will multiply this term. So we will get x divided by a into a minus x, which is equal to kt. And now we will rearrange it, and after rearranging we will get k2 is equal to a by 1 by at into x by a minus x, and this is the integrated rate law equation for second order reaction. This is the integrated rate law equation for second order reactions for case 1. This is rate law equation for case 1. This is rate law equation for case 1. Understand? क्या क्या मिल गया? कौन सा इक्वेशन मिल गया आप लोगों को? K2 is equal to 1 divided by at into x divided by a minus x. This is the rate law, integrated rate law equation for case number 1. That is only one reactant is present. That is only one reactant is present. Okay. Now we will start with the case number 2. Now we will start with the case number 2, and case 2 is a plus b gives you product. Case 2 is a plus b gives you product. Here in case 2, two different reactants are there. Here case 2, two different reactants are there. Please remember this. And if Ca is the concentration of reactant A and Cb is the concentration of reactant B at a time t, then the rate equation will be rate is equal to minus dCa by dt. This Ca is nothing but the concentration of reactant A by dt. D by dt, it is a small change in the concentration, and negative sign indicate the decrease in reactant concentration. Again, for another reactant, that is reactant B, we will write minus dCb by dt. Here Cb is the concentration of reactant B and d by dt is the small change in concentration, and negative sign indicate the decrease in reactant concentration. Okay. So here we will write down the rate equation. R is equal to K2. K2 is the rate constant for a second order reaction, C square A into C square B, and this C square A and C square B is nothing but the concentration of reactant A and B. This is our equation number 1. This is our equation number 1. Okay. Now again here please remember two sub cases are there. Case 2 contains again two sub cases. So two sub cases present in case 1. Sorry, case 2. In case 1 no sub cases was there. Okay. Here two sub cases are there. Now we will discuss the sub case 1. We will discuss the sub case 1 with equal initial concentration. This is your case number 1. क्या है case number 1? With equal initial concentration. किसके equal initial concentration? This reactants A and B. That means what? This reactant A and B, they reacts with equal initial concentration. We have taken their concentration equal amount. We have taken A and B in equal amount. So this is the case number 1. And case number 2 क्या होगी फिर? With unequal initial concentration of reactant A and B. Case 2 क्या होगी? With unequal initial concentration of reactant A and B. So first let us start with the case subcase 1 with equal initial concentration. That means we have taken concentration of A is equal to concentration of B. इन दोनों का concentration क्या है? Same लिया है हम लोगों ने. This is the subcase 1. Now, if A is the initial concentration of the reactant A and X is the number of moles of the product form at a time t, then the concentration of unreacted reactants A at a time 2 will be A minus X mole. A minus X mole, and which is nothing but the Ca, which is nothing but the Ca. And here in case we have taken Ca is equal to Cb, because दोनों का initial concentration क्या है? Same है. So Ca is equal to Cb will become A minus X. अगर Ca is equal to Cb है और इसका concentration A minus X है, so it is similar to the case 1. It is similar to the case 1. So please remember that subcase 1 is similar to the case 1. Subcase 1, it is similar to the case 1. So we will get the rate equation, integrated rate equation, which is similar to the case 1. ये हम लोगों को मिल जाएगा. If you solve this reaction, if you solve this equation for this subcase 1, you will end up with this equation, which is similar to the case 1. So subcase 1 is similar to the case 1. Please remember that. Subcase 1 is similar to the case 1, which, and after solving we will get this equation. K2 is equal to 1 by AT into X by A minus X. So subcase 1 is over. So subcase 1 is over. Now we will start with the subcase 2. We will start with the subcase 2. So here subcase 2 is what? With unequal initial concentration. That means the concentration of A and concentration of reactant A and concentration of reactant B is not same. That is called as a subcase 2. That means the concentration of reactants are not similar, they are unequal, and for this unequal initial concentration we have to find out the rate constant. For this unequal initial concentration we have to find out the rate constant. How? Let us see. Let the initial concentration of reactant A and reactant B be A and B mole. क्या है? Initial concentration reactant A का small a and reactant B का small b mole respectively. So X is the mole of reactant. Each reactants react to form a product in a time t. X क्या है? X is the number of reactant which react and forms a product at a time t. So the unreacted concentration will be A minus X for reactant A and B minus X small for reactant B. So unreacted concentration क्या होगे? A minus X and B minus X for reactant A and B, and these are nothing but the Ca and Cb, and these are nothing but the Ca and Cb. Now we'll put this value in equation 1. This is your equation 1, and we'll put this above value in the equation 1. So minus d A minus X concentration of A minus X by dt minus d concentration of B minus X by dt. So we'll put this value in equation 1, and dx by dt which is equal to K2, dx by dt which is equal to K2. Here K square A is nothing but the A minus X and C square B is nothing but the B minus X. We will get the equation number 2. We will get the equation number 2, and now we will rearrange it. We will rearrange the equation number 1. So in the rearrangement, what we will do? We will take this dt term to the right hand side, and this A minus X, that is concentration term, A minus X and B minus X we will take into the left hand side, and after rearranging we will get this. See here, see carefully. After rearranging we will get this. So after rearranging we will get this dx divided by A minus X into B minus X, which is equal to K2 dt. This is our equation number 3. This is our equation number 3. Okay, so let us start with the equation number 3, which is dx by A minus X into B minus X, which is equal to K2 dt, and we will integrate this equation by a partial integration method. I will not solve this equation by a partial integration method because it is a mathematical term. You may practice by your own. Okay, I will directly give you the result. So what is the limit for partial integration? Limit is x is equal to x and x is equal to, sorry, x is equal to 0 to x is equal to x, for x, that is concentration term, and for time term t is equal to 0 to t is equal to 2, we will get this equation. I will write here direct equation. I will not solve this equation by a partial integration method. It is a mathematical part. You can solve, you can try at home by your own. Okay, so we will get k2 is equal to 1 divided by a minus b into t ln b into a minus x divided by a into b minus x. So here log is ln, so we'll change the base to the 10. We'll change base to the 10. After that we will get k2 is equal to 2.303 divided by a minus b into t log b into a minus x divided by a into b minus x. After changing the base 10, we will get this equation, and this is the rate equation. This is the rate equation for sub case 2. This is the rate equation for sub case 2. Okay, it is the rate equation for sub case 2. It is second order rate equation for sub case 2. Okay, understood? If you have understood, please tell me, then we will go to the characteristics of the zero order reactions. So these yes order reactions na thoda complicated hai, bahut se sare cases hai, so you have to practice. Take a pen and notebook, or you can take a party and pencil also, and do the practice. Then and then only we will understand each and every term of this equation. क्या है second order reaction में? First there are two cases. कौन से cases है? Case 1 is only one reactant is present, and case 2 is two reactants are present, that is A and B. In case 1 only one reactant, that means exponent of concentration term will be 2, and in second case exponent of concentration term will have 1 for each reactant. And again for case 2 there are two sub cases with equal initial concentration, that is sub case 1. Sub case 1 is nothing but the case 1, and sub case 2 is with unequal initial concentration. ठीक है, समझ में आप लोगों को? Okay, then we will see the characteristics of the first order reaction, not zero order reaction. Please remember, not zero order reaction. वो मैंने कॉपी पेस्ट करके लिया. इट इज अ सेकंड ऑर्डर रिएक्शन. ठीक है, इट इज अ सेकंड ऑर्डर रिएक्शन. यूनिट फॉर सेकंड ऑर्डर रिएक्शन हियर आल्सो. Here also. Now I will take this equation, which is the rate integrated rate law equation for second order reaction. K2 is equal to a minus 1 divided by at into x divided by a minus x. Now here this a minus x, if you see this x is what? X is concentration, and divided by a minus x is again, it is a concentration term. Again it is a concentration, so this concentration term cancels this concentration term. So again here a is there, again here a is there, so a is again a concentration term. A is again a concentration term. So what will be the unit? See here a minus x is concentration term, so it get cancelled, and one more concentration term is present at denominator, this a. So the unit is nothing but the per concentration per time. Unit is nothing but the per concentration per time, and you know that concentrations are generally expressed in mole per liter. Concentrations are generally expressed in mole per liter divided by time. If you solve, you will get liter per mole per second. If you talk about the SI unit, this is the unit of second order reaction, liter per mole per second. Liter per mole per second, the unit of second order reaction. Then we will see the half-life period. You know the half-life period. What is half-life period? It is a time required to complete half of its initial concentration. It is called as a half-life period, and at t half a is equal to a half and x is equal to x half. So we will put this value in equation, this equation, that is integrated rate law equation for second order reaction, and after putting this value we will get k2 is equal to a divided by a minus t. So here instead of t we will put t half, and instead of x we will put a by 2, and instead of a minus x also we will put a by 2. See this a by 2 will get cancelled, a by 2 will get cancelled, and you will have only k2 is equal to 1 divided by a t half. And if you rearrange this equation for t half is equal to, we will get t half is equal to 1 divided by K2A. This is the half-life period for second order reaction. This is the equation for half-life period for second order reaction. T half is equal to 1 by K2A. This is half-life period for second order reaction. Then the third property we will see the nature of graph. Third property that we will see the nature of graph. So we have this equation K2 is equal to 1 divided by AT into x divided by A minus x, which is a integrated rate law equation for second order reaction that you know very well, and we will rearrange it. So by rearranging, what we will get? So what we will do, we will take this A divided by x divided A minus x to the left hand side. So x divided by A minus x, which is equal to A K2T. So this we will get, and another way we will rearrange it, 1 divided by A minus x equals to K2T plus A by 2. So in two ways we will rearrange it. This is the first way and this one is a second way. So we will talk about this first way. This first way is nothing but the y is equal to mx. First way is nothing but the y is equal to mx, and if you plot the graph of x divided by a minus x versus t, we will get the equation straight line passing through the origin. So this we will get. So at the y-axis we will take x divided by a minus x. At the y-axis we will take x divided by a minus x, and at the x-axis we will take time. And this equation suggests that it is a straight line passing through origin, which is slope is equal to AK2. And if you write this K2 is equal to slope divided by A. So by using the slope you can find out the K2. By using the slope you can find out the K2. And again, if you plot for this second way, for this second way, if you plot the rate equation, अगर इसके लिए आप लोग प्लॉट करोगे तो what we will get, we will take on y axis 1 divided by a minus x. On y axis we will take this, and on x axis time will be there. So after arranging, if you see, this equation is nothing but the y is equal to mx plus c. Here we will take b. Y is equal to mx plus b. So this is your y. X is nothing but your time. And this m is equal to nothing but the slope. And b is the intercept on y-axis. So we will get the line which is a straight line like this. And if you take a slope of this line, which is equal to slope is equal to K2. And here intercept is present on y-axis. It is nothing but the 1 by a, which is nothing but the 1 by a. So this is for the case 1. This is the nature of graph. Two graphs are there for a case 1. Now now case 1 and sub case 1 is similar. So it is similar to the case 1. It is applicable to the case 1 and sub case 1. It is applicable to the case 1 and sub case 1. Now we will see the sub case 2. Now sub case 2 is nothing but the with unequal initial concentration. Sub case 2 is nothing but the with unequal initial concentration, and which is equal to K2 is equal to 2.303 divided by a minus b into t log b into a minus x divided by a into b minus x. And if you rearrange that, we will get this log b into a minus x divided by a into b minus x, which is equal to K2 a into b a minus b into t divided by 2.303. And in second time after rearranging, so what we will do, log b by a plus log a minus x divided by b minus x, which is equal to K2 a minus b divided by 2.303t. So you will get this equation, and we will rearrange this equation, log a minus x divided by b minus x, which is equal to K2 into a minus b divided by 2.303t minus log b by a. And if you see this equation, it is nothing but the y is equal to mx plus c. And the graph for this reaction is, if you plot the graph of this reaction, it is like this. If you plot graph, here we will take log of a minus x, here we will take log of a minus x divided by p minus x, and here time is there, on x-axis time is there, and you will get the straight line which is having the intercept. So we will take first slope is equal to, you see here, slope is equal to k2 a minus b divided by 2.303, and if you take this in terms of k2, you will get slope into 2.303 divided by a minus b. So by knowing the slope and the value of a minus b, you can find out the rate constant for second order reaction. So this is the nature of graph for sub case. It is the nature of graph for sub case 2, that is with unequal initial concentration, ठीक है. So in this way you can find out the graph or nature of graph, ठीक है. If you have understood this, then it is okay. Otherwise you can try, take a pen and notebook and you can try it, ठीक है. So now everyone is saying yes sir. जब हम लोग यहाँ पे करते हैं ना स्क्रीन पे, तो ऐसा लगता है कि यार मुझे समझ में आ गया है सब, लेकिन जब आप लोग खुद से ट्राई करते हो ना, तो वो आता नहीं है. So for that you have to try it. You have to do it many times. ठीक है. Now I will active the link for your attendance. Give your attendance. Attendance is very, very important. Give your attendance. Any problem? अगर अभी प्रॉब्लम नहीं है तो ठीक है, आप लोग इसका स्टडी करो घर पे जाके, तब आप लोगों को प्रॉब्लम आ जाएगा. देन यू कैन आस्क मी, ठीक है. देन यू कैन आस्क मी. अभी तो आपको कुछ प्रॉब्लम नहीं आएगा उसमें, आई नो दैट. Okay. Pramodini is saying, sir, we will practice. Very good. Practice karo. Practice makes man perfect. Please remember this. So I have activated the link for your attendance. Give your attendance. If no problem, then we will stop here. अगर कोई problem नहीं है तो, and we will meet tomorrow. We will meet tomorrow at 10 a.m. ठीक है. So shall I stop here? Shall I stop here? Okay, chalo. Bye bye. Take care. Have a good day.